Hey, welcome to 16-Bit Bench. Matt here. I'm just going to start the video first with a caveat. This is a very long and rambly sort of explanation of the Super Nintendo. So what I'm putting up on screen now is some times you might want to jump to. So to start off, we discuss the sort of project that we're looking at and what we're going to do. Then at this time, we have the installation of the switchless mod chip. And then at this point we do the capacitor replacement for the entire thing. So if you're interested in either of those two and not the whole thing, then jump to those two times there. Otherwise, sit back, relax and enjoy the video. Here we go. Hey, welcome to 16-Bit Bench. What the hell happened here? Look at it. So this SNES took a nosedive off the shelf a few weeks back, and because, as you can see, it's very yellowed, the plastic is extremely brittle and it shattered like an Easter egg, which is sad. So I put a post out on Facebook and shared it in some groups for ideas of what to do. What should I do with the Super Nintendo? Should I try and reconstruct the case, which clearly now I've taken it apart is impossible. It's bits of it are dust. So should I try and reconstruct the case? Should I buy a new case from China? Mod it in some way? Should I put it in a cigar box? Someone suggested a wooden lined lovely cigar box. Yeah, there were some good ideas there. The one that really stuck out, and the one I was kind of already decided on really, was a handheld. So what I've done is removed the main board from the carcass of the SNES. And then we have the two controller ports on the front, connected by a ribbon cable and an LED to indicate the power. So I'm looking at the board and I can see that there's room to reduce it. Like this massive heatsink is there for an LM7805 linear regulator. So this is dissipating heat. So obviously that can be replaced with a switching regulator, which gets nowhere near as hot as that. The extension socket on the back could probably be removed. And this big capacitor, there's a big capacitor in here, you see this big fat guy. That could be replaced with something maybe a little bit smaller. What is that? 2.2 millifarad capacitor. So maybe I could replace that, or maybe we could put it horizontally or something. So yeah, what I'm thinking is a handheld. This would be the front of it. So you'd probably hold it like this. We'd have the controls down here. So I'd probably have basically an NES pad here, and then there would be plugs out of the top. Say these would come, say, out the bottom here or out the top here, and we run extensions on this to there. Yeah, cartridges will plug the same way in, kind of vertically in the back there. I might retain some of the good plastic. The dark grey plastic is in good shape and it didn't shatter when it hit the floor. Maybe that forms some of the back somehow. Like that. Something like that on the back. And we do something with these buttons. Maybe I'd leave the power actually. Yeah, and the rest of it obviously some kind of 3D print or laser cut thing a la Ben Heck for the rest of it. So yeah, so all I'm doing now is I'm just looking at it, I'm taking it apart, figuring out what's going on. Haven't tested it, so I don't even know if it works. So if you're not watching this and you've never seen this, then use your fifth dimensional eye to understand that when I tested this board it didn't work, so I just threw it away, or I tried to fix it. Yeah, so next step is to find a power supply and an AV cable for the SNES. I've got some games, we'll plug some games in, find a controller and test it, make sure it works. Good news, the SNES works. It's also, because it's a French model, it's RGB native out. I'm not sure if all SNESs are, but this one certainly is, so it's a lovely crisp RGB image. Went through my huge box of controllers and I don't have any Super Nintendo controllers, which is annoying. So I'm going to need to order one from eBay just so I can do the rest of the build and sort of test it as well. I want to make sure it works before I start getting too hard into it, but I'm not too worried about that. I'm sure that will work if the rest of it works. The board is a little bit dirty, but it's not terrible. There's a tiny bit of corrosion here and there, but it's not devastating. So yeah, this is a good thing. I think we can move forward with this board. First thing I'm going to do is replace the regulator with a switching regulator, and then get rid of that massive metal heatsink that you can see there. So we've confirmed the board works, and I'm in the process of replacing the 7805 1 amp 5 volt linear regulator with a switching regulator of comparable power. I thought I had one, but I've used them up in previous projects. I'm going to have to order one. It occurred to me I was looking at the board, and then I realised this black thing here is a bridge rectifier. It turns AC into DC, and then that's what this big capacitor is doing, is smoothing it out. So then I remembered that the Nintendo and Super Nintendo power bricks are AC, are 9 volts AC. So it looks to me like if I take 5 volts directly into the regulator once I've replaced it, or sorry, 6 or 7 volts directly into the regulator from a battery, I don't need any of these components. So this big capacitor can go, and that'll free up space, and maybe I'll take out the bridge rectifier as well because it's kind of bulky. Then I'm looking at the board. There's a whole host of 10 microfarad capacitors. One of them is definitely on the way out. So they can all be easily replaced. And if you've seen my videos and you've seen the Game Gear recap video, there I talk about how to get these guys off. But basically you just, the easiest way I found, because they're surface mount and they're soldered underneath, is to take a pair of pliers, grab it so you're on the opposite axis from the solder. So on these two, the solder is going this way. I'm grabbing it at the opposite axis, and then you rock it back and forth and slowly ease it up. And what will happen is the legs will come out of the can, and you can just throw the can away and desolder the legs. So yeah, that's one of the things I'm going to do. Replace the regulator with a switching regulator, remove the AC coupling components we don't need anymore. That means the jack will go as well, and then the only way I could power it is by hooking up a power source of between 7 and I think it's about 36 volts the regulators take. So any power source with higher than 7, less than 30 will be fine for powering the Super Nintendo from then on. So I'll do that, and then we'll have to look at batteries and charging circuits and all that kind of stuff, and then building an enclosure. But yeah, I think the first thing to do is just modify the board, recap it, and get it optimal. I think what I'll also do is remove the external link connector, which is this guy here, just because it's taking up a load of space and I don't need it. It was never used for anything, was it? They never released the Super Nintendo CD attachment, as far as I'm aware. This was never used for anything. So yeah, that's it. And once that's gone, the board will sit flat as well, because at the moment it's. So I'm just starting to modify the SNES board for inclusion into the handheld. So I was looking at a schematic of the power diagram, and I'll show you that on the screen now. This is linked in the description below as well. This is from console5.com, and they have schematics for, I think, all of the models of SNES that are available. So I was looking at the power diagram, because as you know, as I mentioned, I want to get rid of the AC 9 volt AC input, and I've already desoldered that from the board down here, so that's gone. And I want to see if I could power it directly with DC into the linear regulator. So by bypassing all this stuff here, you see this capacitor and this little black thing here, they're all AC circuitry. The black thing is a bridge rectifier to turn AC into DC, and the big capacitor there is to smooth out the waveform after it's been converted. And then that signal is then fed into this black guy here with a little tab on, and that is the linear regulator that takes the signal anywhere up to 36 volts down to 9 volts. So what I'm doing is I've wired directly to the input and ground of the linear regulator, and that's what these two croc clips are on here. and that goes to my bench power supply, which is currently set at 10 volts. So I turn that on. It bypasses the, you can hear in the background, I know it's working, it bypasses the power switch. The power switch isn't even connected, it's here. So the power switch must be downstream, and if you look in the diagram, the power switch is upstream of the regulator. So that's so the regulator is disconnected when the power, which makes a lot of sense because the regulator burns a lot of voltage when it's on. Let's just turn that off for a sec. When the regulator is on, it burns a lot of voltage. So you want to have your switch upstream of the regulator, so that's disconnected from the voltage when this console isn't turned on, and that's the case. Yeah, so by wiring directly to the regulator, I can feed it a DC source, and I don't need to worry about the AC. To cut a long story short, we can get rid of all of the AC components. So that's removing that big, the big capacitor here, and the little capacitors around it, and the regulators and the optical isolators that are here. They can all go. So that saves space on the board. It makes the board smaller as well. One thing I need to test. So let's turn it on. So does the reset button still work? Yes, it does. Just try not to get a copyright strike from Nintendo. Yeah, that's good news. We can remove a lot of these bulky components we don't need, and we can power it directly with DC. So when I'm looking at batteries, I'm going to need to have a battery that's about a battery output that's about 10 volts. Well, no, actually, let's test that. Let's turn it on. And let's record it. Let's turn the voltage down very slowly, and at what point does it start to break? That point. Yeah, it's not happy there. So that's what I'd expect. That's about 7 volts. So the 7805 regulator, the minimum operating voltage is 6.5 to 7 volts, depending on the exact type you've got. This is an older one, like an MC7800C or something like that. But it's the same thing. It's this linear it's super hot already, and I've only had it on a few seconds. So that's okay. So I know it looks to me like the 11.5 volt thing is not important at all. It's not needed. So that's really good. We don't need to worry about that. We can remove the downstream AC components. The power switch will need to be relocated. So the input of the power switch is our output of our batteries or our charger. And then the output of the power switch goes to the input of the switching regulator that we're going to replace this guy with. So that's pretty easy stuff to do. So I've started removing components that we don't need. There's not that many really. If you look at the circuit diagram, there's a lot of small ones, but you know these are the 3 biggest ones. So we've got an opto isolator that's sitting on the AC input. That's the thing on the diagram that looks like a circle with 2 bombs in it. Then we've got the rectifier. Yes, it is a rectifier. Yes. So there's a bridge rectifier here. It's 4 diodes in a pattern. This is what a bridge rectifier looks like. Here's another picture. And basically it creates a DC signal from an AC signal by kind of reversing the polarity of the flow so they're all above 0. And then you have a big fat capacitor to smooth out the signal. I realised that the big fat capacitor is actually sitting across ground and the DC line. So what I've done is I've connected my wires to the 2 holes that the capacitor was in. So my plus voltage is flowing into my plus side, and my negative voltage will be on the negative side. So those 2 wires that are in the board now, I've removed the capacitor, are actually quite useful to use for wiring to. And that's what I've done here. So I've wired my bench power supply to those 2 points. Now these 2 points are upstream of the switch. So now we're back to the situation where the switch works. So if I flick the switch, it powers on. and it powers off. So I've put the switch back in line now. This is now working. So we're no longer coming directly into the regulator because that was not best practice. We've got a switch now back in the circuit. So yeah, that's cool. So that's sort of simplified this area massively, really. I didn't really want this in there anyway. So yeah, these components are now in the spares bin. So let's do the region 3 mod now. I've installed the switching regulator here. That's that little green package you can see. If you saw my Spectrum video, you'll know that the pins on these things are the wrong way around and you have to install them on the other side, which is silly. So people, it's too late for the people who make those to change it, but you know, really. Okay, so what we need to do is follow one of the multiple guides out there. I think I'm going to pick this guy called MMMonkey or monkey.co.uk, and that's linked in the description, just because he's a little bit clearer than the other ones I've read. So we'll follow his guide. What we're going to do, what I've already done, is I've modded the controller board. I've removed the LED, you can see here, and it's now replaced with a dual color LED. This one is red and blue. Common cathode. So I've wired the cathode down to ground there, and it's the middle pin, and then the red and the blue have 180 ohm resistors coming off here, and these will go to the PIC. So this board is now modded, and we don't really need to touch that anymore. So we'll do the work that needs to be done on here, and it takes place in this area. So what the chips we've got are the two PPUs here, the CPU, there's some RAM here, big RAM chip, and down here is the CIC chip. So this is the one that's doing the region protection. And what we're going to do is lift legs 1 and 2 and 11 and 10 and 11, and that disconnects power to this chip, so it makes it dead. And then we'll replace it with our programmed PIC, and we'll run wires all over the place. Okay, so I'm going to get on with that work, and I'll record it while I do it, and I'll interrupt every now and again if something interesting is happening. What I'm going to use is this rainbow cable because it's super cool. And yeah, this is multi-strand cable. I think if I had single strand cable of the right thickness, I might use that instead. But the multi-strand cable is more flexible, and it's a bit easier to use. But you do have to tin the ends before you use it. Make sure you don't get any strands sticking out in different directions. So yeah, so let's lift all the pins that we need to lift, and then we can wire up the PIC. Okay, so in order to lift the legs, I've put the fine tip on my soldering iron. So I usually use the chisel tip for most things, just because you get used to it and you don't really want to switch around. But yeah, there's a fine tip on there. And all we have to do is just heat up the pins, and I've got a pair of very sharp tweezers. So what you want to avoid is having the tweezers on the leg while you're trying to lift it up, because then you've got to heat the leg, the solder and the tweezers, and you don't really want your tweezers to get hot. So we heat up the leg, and then we come in with the tweezers at the end. So like I said, what we're doing is 10, 11, 10, 11, 1 and 2. There we go, that's 10 done. Once you've got 10, you can get to 11. And you can just remove the CIC chip and then replace it with a resistor. And that's in some guides. That's a destructive modification, and I'd like to avoid doing destructive modifications on rare parts. The CIC chip is a custom spun part for Nintendo, so it's not like you could just order one from AliExpress or any kind of parts warehouse. They don't stock them, so if you did ever need to reinstall it, it's going to be there on the board. I'm not going to remove it. Okay, so the next step to do is there's two PPU pins that we need to lift because we'll be sending signals to those PPUs. So on PPU 1, we'll be lifting leg 24, and on PPU 2 we'll be lifting leg 30. So if you look at PPU 2, leg 30 is the outside leg, so that's pretty easy. Leg 24 obviously is going to be 6 legs in from pin 30, so that's a little bit harder. So let's do the easy one first. There we go. And then pin 24. So we count, we go to pin 30, 29, 28, 27, 26, 25. You actually see that they're very good with silk screening on the board. So every 5 pins are marked with a circle. So I know pin 25 is the circle, pin 24 is the one next to it. So that makes our life a lot easier. So let's heat pin 24 and just give it a little bit of heat from the iron, and then we'll just leave it under it with the sharp tweezer. Ooh. Fiddly job. Try and avoid fiddly jobs if at all possible. One of the first mods I ever did was a PlayStation 2 mod chip back in the mid 2000s, I'm going to say, and that took ages because that was a very fiddly job at the time. Shortly afterwards they just released hats that you could just plug on top. Obviously they were way more expensive. Let's try my scalpel. I don't think it's much thinner than the tweezers. Yes, they just released hat mod chips that you could just plug on the top. 30, 29, 28, 27, 26, 25, 24, just making double sure. Yeah, I must have taken that PlayStation apart about 8 or 9 times to get that chip right, because you couldn't even power it on if it was in pieces. There we go, pin 24 lifted. These 2 pins you're going to be soldering to, so you don't want to really mess about with them too much. Okay, so now we'll be soldering the pick, and I'll have to look at a wiring diagram for that. And what I think I'll do is I'll put the wires on it. I'm gonna wire it in what is colloquially referred to as a dead bug configuration. That's just where you bend all the legs up, and quite often what they do is sit it on a, I'm going to sit it on a bit of non-conductive foam, probably about here, and just maybe put a bit of hot glue on it, and then that chip will just sit there. So yeah, I'll bend the legs up, and then I'll solder wires to the legs I need to have wires on and in color code, and then we'll come back when I'm ready to start installing that. The first step in the Switchless mod for our Super Nintendo handheld is going to be programming a controller, a PIC. And this replaces the function of the CIC chip inside the Super Nintendo and makes it region free. So then we can play, Japanese and American games on our PAL console. So there are some good guides. I think the definitive one is this one by Wolfsoft. He mentions the mod is using a PIC 16F630 with the following code. Now we download that code, and inside the folder there are 2 files. There is a lock and a key, and it doesn't mention in the guide which one you're supposed to use. And as far as I could find, no one has definitively said it's this or that in any of the guides I found, until I found the guy who actually wrote the code. So it says here, the console one will be the lock and the cartridge will be the key. So in any pair of Nintendo pair of console and cartridge, the lock is in the console, and the cartridge is the key that unlocks the console. So it detects it's a PAL cartridge, it's a PAL lock, it's unlocked. And that's actually kind of the same way it worked in the NES with their region lockout chip. But in order to disable that, it just needed to be depowered. It sort of was open when it was turned off. The Super Nintendo one is more complicated than that. Obviously, they learnt their lesson. So now we know that. We know how we can proceed with programming our controller. With that software comes a program, and the program is called Mini Pro, and this is how we program our IC. So in order to select your IC, you go to select, search and select, and in the search device you type PIC 16F630. It gives you one manufacturer, microchip, and then a list of devices. So I've got the PIC 16F630 one at the top, and then SOIC and TSOT packages, and then different flavors as well. We're only interested in the top one. That's the DIP package that we have, so we'll select that. We can go to device and read. Reads it in a couple of seconds, and we can see it's all full of ones. So what we now need to do is open up our Super CIC file. So we are the lock, because we're going in the console, so open the hex file for that, and you can see programs now open, and there's the program in there. It's not very big. Then we can program our PIC, so just click on the big P microchip and then the program button. And there we go. So all done. The PIC's now programmed, and we can move on with following the guide here to actually install it in the machine. So I've just got a Mini Pro generic Chinese kind of programmer that I got off eBay for I think about £20, and in it is my PIC 16F630, and they're very cheap. You can get, I got about 5 for about £5, and again I'll link in the description where to get this. I've wired up the PIC here and I've glued it to the board. So what I've done is taken a bit of non-conductive foam, and this is the kind of stuff you get usually chips. When you buy chips, they're usually stuck in this stuff. Well, you could use anything, a bit of plastic, a bit of cardboard, really anything that's non-conductive. And I've hot glued that to the board, and then I've hot glued the chip to the foam. So if we take a closer look at what's going on, I haven't really started wiring it up. So there are a couple of ways to do it, and really what I would suggest is if you're watching this video, also follow a guide, an online guide, and there's some linked in the description, as I've said. So here we have the CIC chip, and here we have the mod chip. Some of the legs of the mod chip are to ground, so there's a bridging wire across here taking pin 7 to pin 14, which is ground, and then there's pin 4 here to pin 1, which is 5 volts, and we're taking 5 volts from pin 18 of the CIC chip, and we're taking ground from the pin is that pin 1? No, it's pin 9 of the CIC chip there. So now what I've got to do is start soldering in the rest of the wires as per the guide that I've got, which, as I said, was the MMMonkey one. Yeah, and so we'll do that, and then we'll test it. Okay, so that's the wiring on the PIC done, apart from the LED wires. which I'll do in a second. Let's just take a look at the how I've laid it out here. So there we have pick in dead bug configuration, so his leg sticking up. Hot glue to the board with a piece of foam. You can see the green wire. That's what's setting the video mode. So I think it's when this pin is high, it's in 60 Hertz, and when it's low, it's in 50 Hertz. So that will be controlled by the pick. Off the top there, that's our LED wires, and then off the side of the pick are all the connections to the CIC. So you've got there, and this is just as per the guide. And there are a couple of different ways to do it. These signals aren't exclusive to this chip; they're all over the board. You can pick them up in a variety of places. So what you need to remember is this chip is disabled, so you're soldering to the pads, not to the pins. Whereas these chips are enabled, so you're soldering to the pins, not to the pads. And that's all you need to remember when you do that. So what we should be able to do now is hook up the LED and see if it works. So here we go, the Nintendo's all plugged in. I've only got 2 Super Nintendo games, but conveniently enough, this one is a PAL game and is good, and this is an NTS game and sucks. But it proves that it works. So we plug in our PAL game, we turn our console on. The red LED indicates that I've left it in PAL mode. If I want to change the mode, I hold down the reset button. It's now purple. Purple indicates auto mode. That means that it will just detect what the cartridge is and switch to the appropriate mode. And then blue, that's NTSC mode, and that will force the PAL cartridge to play as NTSC. If you want to reset the console, you give it a quick press. So trust me, it's working. You might be able to hear the music, but there's no point in showing you the picture. My TV doesn't identify if it's 50 or 60 Hertz. It doesn't say on the TV. It just is. And it's not like the games run at different speeds like they did with the older consoles. It runs, the same. So that's it. That is the switchless mod. So it's all controlled by the reset button. Let's turn it off and try the other game. Let's turn that on. Yeah, that's working. Auto mode, reset the console. And there we are. So previously, before the mod, this game wouldn't work at all, and now it does. So now our Super Nintendo is completely region free. Let's turn it off. So before we conclude this first part of the handheld video, there is the recapping to do, and I'll show you that in a minute. And after that, that's it. We're done with the board, and we will move on to the design phase of like the handheld enclosure, 3D printing parts, and figuring out how that's going to work. And I'll show you the screen I've got and that sort of stuff. Right, let's get on with recapping this board then. So there's a load of 10 microfarad capacitors here that we're going to replace. I'm replacing them with electrolytics. These are good quality caps. So I'm not replacing them with the cheap rubbishes here. And the other thing is, some of these, like 59, are no longer actually in circuit, but I'm replacing them just because I can't be 100% sure which ones are in circuit and which ones aren't. So that's why I'm doing that. But yeah, 59 I can see is coming off the leg of the diode there. So I know it's not in circuit anymore because I removed that component, but the others I'm not so sure about. Some of them just go to ground as well, so they're smoothing capacitors for some of the DC power. So yeah, what we'll do is replace all these, and then we'll be able to look at. Okay, so these radial sort of cans are a pain in the ass to desolder because they're actually soldered underneath. They're surface mount components, obviously. And the solder paste is mostly underneath them. You can see to either side there is a little blob of solder, but melting that off often doesn't do you any good. So we brute force, pair of pliers, you grab the can in the opposite direction from where the solder's going. So if the solder's going, say, east to west, you're going north to south. And then you just gently give it a wobble. And what you're doing is you're pulling the legs of it out of the can. And then what will get left on the board most of the time are, there we go, the can's out. So what you get left on the board are the two legs out of the capacitor and then the black plastic cap, sort of little seat that it sits in. So we can just snap the plastic off. That reveals the solder pads and the two legs and a little bit of looks like electrolytic material that has come out of that capacitor. So yeah, we'll just go one by one, pulling them off and replacing them. If you've seen any of my other recap videos, one of the things I'm very adamant about, do not pull off all your capacitors in one go. Never ever do that. You know, even if you have a piece of paper, you have a guide that tells you exactly what needs to go where, still, there's no reason to do that. You'll just make your life misery and sad. So just go one by one. It's you know, it's just as hard. Yeah, it's massively easier to do it that way. Sorry, it's early in the morning and I didn't sleep very well. I'm tired. The other thing is to make a note of which leg is negative. So on these there is a black sort of paint on it. That is the negative leg. It's also indicated on the screen printing by a flat side. That is also the negative leg, and in most cases if we buzz it out on that leg we'll find ground there. So let's just do that to prove my point. So hit the ground plane. Yep. So if you buzz out that back leg, that one I know isn't connected to anything. In most all cases you'll find it's ground. I mean, it won't be all cases, but it'll be most of them. So then you can be reassured that that is ground. You are in the right polarity. Putting these guys in the wrong way round is bad. At 5 volts, not that bad. You know, nothing's going to explode. At 25 volts, things are going to blow up. So just be aware. The polarity on electrolytic capacitors is important. The polarity on any component really is important. Okay, so let's get on. I've replaced the electrolytic cans with these electrolytic caps. Boom, 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 boom. Now, in the past, I have talked about surface mounts being more reliable than electrolytics, and that is true. The kind of problem here was that these capacitors were over-specified to be 50 volts. It's very difficult to find. I found at moment of recording, I couldn't find surface mount ceramic 10 microfarad 50 volt capacitors, so I've gone with the Vichy ones here. Now there's no, they're going to last a good long while. I mean, probably longer than the life of this device. So but if they ever do need to be replaced, they're very easy to just swap out, so it's not a problem. Next step is to do some surface mounts that I do have. So I have ceramics for those capacitors there, so we'll do those ones now. Okay, so I have two left to do. There's the 47 microfarad one here, which is on back order, so I will replace this one as soon as that comes in, but we can continue working. And then there's the 2.2, which I've just pulled off. And then I've got these tiny like 3mm packages to replace it with. And what you'll find with surface mounts quite often is they come in these basically they come on big spools because they're designed to be loaded into a pick and place machine. They're not really designed to be used by humans, so they come on these spools and they're really small and hard to work with for a reason, because they're not designed for you to actually be soldering with them. Although, you know, it's not that hard. With a little bit of practice, you know, it becomes very quick and very easy. Just get in there. Pair of tweezers, must have for any of this kind of stuff. Right, so that is I'd say 95% of the recap done. The only one I haven't got to is this 47 here, which we will do at some point. As soon as it arrives in, I will put that one in. Okay, so what we're going to do now is plug the SNES back in and make sure it still works, and then we will talk about our next steps. So we finished the recap, we've installed a mod chip, we've installed the LED for the mod chip. You know, there's a lot of work going into this SNES so far. It's basically in as good a condition as you can get. If you were looking to buy an SNES, you'd want one that has been recapped and probably had a mod chip installed if that's what you're interested in. So I think that brings this video to an end. This is going to be part one of the SNES Handheld project. Part two, we'll talk about videos, screens, and batteries, possibly, and controls. And we'll start looking at enclosure options and how we're going to do that. So if you found this video useful, please like and subscribe. Follow us on Facebook, Twitter, and Instagram. It's 16BitBench. This will be an ongoing project over the next couple of weeks, so we'll see it evolve as we go. I think this video stands pretty well on itself as how to do a mod chip and a recap on a Super Nintendo. So, you know, hopefully people find it useful for that reason alone. So yeah, thanks for dropping by, and we'll see you next time.
What the hell?